So this is the session question for topic 7, session question 1. So the question was, in what situations might you choose innovate over linear regression or vice versa, and provide a real-life example and explain how you would approach it. So innovate is an analysis and variation in regression and linear regression are both statistical methods using to analyze data, but they are chosen based on different scenarios and review questions. So the first part I'm going to show is the analysis and variations. So the purpose of it is to test a hypothesis that is appropriate to compare means of a continuous error of 2 or more independent comparisons. The type of data, dependent variable, continuous, and then independent variables categorical. One to use when you want to test particular hypothesis between groups. Hypothesis to know, no difference, and then no difference between the groups, and the alternative is at least one difference significant over the mean. The output to be box plots, Shapiro-Wilk test, or a homogeneity of variance. A real-life example is an example about participants being separated into 3 separate categories for bipolar, control, and depressive. The approach is the analyst to figure out the right answers, and then justification would be suitable means for each category. So right here, I'm importing all the libraries I need for the interview section. This part here, it's reading the CSV file. This is all the information within the CSV file. The description, the group, so bipolar, control, UD. Type, control, beat, bipolar 1, bipolar 2, UD. And then this is also how the groups were divided. The visual, so the count and the minimum and max, the mean and standard deviation of each of them. So bipolar, control, UD. The first one is a box plot. The blue one is bipolar. The orange one is the control group, and the green one is the UD. The one way, so the hypothesis, the null hypothesis is the expected value of the right answers in the same, and the alternative is just the alternative. So right here I'm importing the groups so to read it. Here it's reading the groups. And here it's knowing the group's net values I need. And right here it's giving me the results I want. So statistical 59 to 0.28, p-value 4.01. So the next part of the DQ was the linear regression. So for linear regression, the purpose is to estimate the y changes when the x changes by 1 unit. It's usually a dependent variable, which is continuous, and when to use it is when the continuous outcome of variables. Hypothesis used to confirm beta coefficients are significant, and output is using the best side of fit. The example I'm using is the medical insurance personal. So here I'm importing the libraries I need. Right here I'm reading the CSV file, which is the insurance file. The shape, what is inside of it, anything missing, and right here, this is a line LM graph. So a plot between BMI and changes, so the changes is here and the BMI is here for each significant human, for each significant person. The description, so the ages, the BMI, children and charges, count, mean, standard deviation, min, 25%, 50, 75, and max. The correlation is basically the same as that up here, but it's just the age, the BMI, children, and the charges. And this is the correlation heat map. So that results are here so you can see it. This section here is a subplot, so the charges versus the count. Here is the charges versus sets, and the charges if they were a smoker or not. So female, the outliers up here, male, the outliers are there. If they were a smoker, there's not many outliers. There's no outliers, and if they weren't a smoker, there's outliers. The array of children, if they had children, children and charges, so the charges and the children. 0, outlier, if there were outliers. 1, there's a few outliers. There's quite a bit outliers. 2, a bit. 3, quite a bit. 4, there's 2 outliers, and 5, there's 1 outlier. So right here, it's reading the file and it's showing you as well. Here it's has categorical column, so it's showing the sets, the children, and smoker, if they were a smoker or not. Encoded charges, so here and here, which is source the value. Then the next part is the actual linear regression of it. So the linear regression intercept is 3.06. Coefficient, the array is here. And the line predict is right here. Mean squared error, 0.033. Linear regression score x test versus y test, 0.002. So each of these data sets are not of Kaggle. The first one is obviously the study with the bipolar attention and depression disorder, and the second one is insurance. So yeah, that's this week's DQ1.